Good morning, everybody. My name is Chandrasekharan. My colleague's name is I. Vignesh. Our project name is Extraction of Windowlin from Catharandus roses and Instrumental Model of Automatic Column Chromatography by using PLC. Our project guide is M. Vanitha M.E. Project done at World High Tech, Dr. Rangaraj and Dr. Sakuntala Engineering College, Avadi. Abstract. Aim of the abstract to produce the windowlin as phytochemical from the Catharandus roses, to determine the quality and quantity test, to develop instrumental model of column chromatography. Objectives. The objectives of the project is to extract windowlin from Catharandus roses by using column chromatography and recrystallization. Catharandus roses, family Apocynaceae, one of the few medical plants which has found mention in the folk medicinal literature 2nd century of before Christ, and alkaloids derived from aerial part of the Privinclin. Common names Privinclin intercalani. Chemical constituents vincristin, blastin, indolin, and asmolation. Applications used in the pharmacology, the anti-cancer drug, namely vincristin, vinblastins, or alkaloids produced from catharandus. Windowlin composition availability of the windowlin component in the root is up to 0.5 percentage. Aerial part of 0.2 to 1 percentage. Temperature should be maintained below 50 degrees Celsius. The structure you can see in the board. Applications of windowlin. Its ability to reduce the blood pressure, anti-cancer drug. Technique for isolation of the component. Drying, grinding, extraction, filtration, separations, column chromatography, recrystallization, chromatography for analysis. Apparatus requirement. Milling or grinding equipment, shaker, distillation setup, vacuum dryer, glass column, TLC chamber, reaction flask setup, solvent, glass accessories, analytical apparatus, HPLC, TLC and UV test. Extraction process. Here we done the leaf from the leaves we got the powdered material. Then we are introduced into the extraction. We got 34 grams of dry powder from the dryer and through crushing. Dryer we maintained 45 degrees Celsius under vacuum at 20 hours maintenance. Then we are sent it to the extraction chamber. It's called as shaker with a conical flask. We added 400 ml of methanol and shaked with 48 hours under 160 rpm. Then we are fed it through filtration and drying. After getting the dried powder, we are introduced into the stage 2. Here, before the stage 2, we did TLC sampling to confirm the constituents is present or not. We had obtained the result as completed. TLC is completed. The product is present. Here we have some difficulty to do the drying of residue. We didn't have the evaporation techniques which is used the rotary evaporator. We didn't have, so we are used directly into the distillation setup as maintained vacuum under the distillations. Up to the 500 Hg we maintained 50 degrees Celsius, not over the 50 degrees Celsius we maintain the temperature. The photocopy of work done stage 1. Collection of aerial part, drying and shaking, filtration, distillation arrangement, distillations. Stage 2. Chromatography screening of the component. We used column chromatography techniques Aluminum oxide as a stationary phase, methanol as a mobile phase. Dry powder is a sample we obtained from the stage 1 and centered everything centered at the fractions was collected down of the column rhodography. Segregation as for the TLC result we got TLC completed which is the fractions as completed TLC, then we are sent to the dry getting dry powder through evaporator techniques up to collection of the fractions is stage 2. Photography of work done stage 2. You see here the pictures which is we are done in the process at a real time. Empty column placed with cotton. Second is illustrations. Third is column illustrations overview. Fourth is TLC checking. Photography of work done stage 2. Here you can see the TLC checking methods. The stationary phase of the TLC silica gel CF GF 254 TLC plate readily made we got from the market. Mobile phase methanol and MDC respectively 2:8. Here the symbol we are mentioned arrow is at Wendolin, star as impurity, 1 and 2 and 3 is on spots pointing the procedures. TLC to check under the UV light, we use the laminar airflow. Stage 3, separation of the Wendolin. From the stage 2, dry powder we are taken for stage 3 and acidified by using MDC and tartaric acid, then filtrated, then layer separation done. From the layer separation, MDC layer which is having Wendolin, that MDC layer separated through evaporation techniques. The aqueous layer which is having other constituents like ajmalin, vincristine, we need to do pH assessment for preservation of the other constituents. Here the ammonium hydroxide as a pH adjusting agent 5.9 up to 5.9 pH we did. Photography of work done stage 3. Recrystallization stage 4. 8 volume of methanol and dried material we are taken and dissolved up to dilution level, and 1 volume of activated charcoal we are added for removing the color impurities. Then filtration we done through Buckner filter followed by the 0.45 micron filters. Then clear solution we taken to recrystallization setup, which is we are used RFA. Here maintenance up to 2 hours, 0 to 5 degrees Celsius under stirring. We got some material falls out in RFA. It's called as a crystalline material formed from the solutions. After maintenance period, filtration we did. For bed washing we added chilled methanol. The crystalline material is called as a Wendolin. After filtrations sending to drying, and then drying is taken 6 hours under vacuum below 40 degrees Celsius. Finally the sample is packed and sent to the sampling. We get the result from the analyst. This is the photography of the work done of stage 4. So growing and filtration Buckner funnels we are showing in this sections. Analytical reports. UV test result is we obtained 300 nanometer, LOD 0.4 white by white, HPLC 85% in stage 3, 92% in stage 4, TLC everywhere and compiled. The HPLC graph was shown here. Top is 80% of the stage 3 we shown, 92% of stage 4 is down. The major peak is windowing, that AB is an known impedance. Before the major peak, it's an unknown impedance we removed in this regression sections. Material balance and cost analysis. Material balance. Stage 4 we got 60% of yield. Stage 3 42% of yield. Stage 2 is 70% of yield. Stage 1 is 29.4% of yield. Material cost. We have the chemical list which is used in this process. Overall chemicals we used totally 1038 rupees per grams. Instrumental model of automatic column chromatography by using PLC and SCADA. PLC means programming logic control. We use the PLC software for developing the instrumentation model. Column chromatography is major critical in the extraction process because of more went out of vapors coming out from the column. So the critical is column maintenance. So column mobile phase maintenance and fractions collections. We are introduced that automatic system by instrumentation model, which is we use the software for developing the instrumentation model. We are used the LiDAR diagram software. Here this is in LiDAR sectors. There are many input and output symbols are there. As per the problem creating, we need to use the symbols which is used in user, bit, time, counter, input and output, comparison, OSR, normally closed, normally open. There are many systematic symbols are there. These symbols are operating and programming the counting and timing. This software belongs to TLP logic programmable simulators. Software details is software RS Logic 500 we used. Supporting software is RS Links Gate. Configuration drivers EMU 501, SLC 500, DH 485. Controller properties is Buell 1761 Micrologics 1000, DH 485. Here we are created problem against column chromatography. The shading parts is shadow part is called a packed column, and the top sections are sample and cotton. The bottom of the column is collection systems. Top of the column is filling systems. The bottom side which is used collecting vessels and beakers and conveyors and conveyor running motors. Then under the collecting vessel, beaker, then bottom side we introduced one of the sensors. The whole setup we are called as an bottom of the column. The top of the column we have sensor, level sensor and valves, mixing zone, then solvent feeding systems. everything connected to the programming logic controller. The bottom section of the collecting vessel, we have sensor like level sensor. The bottom of the column, we have valve and flow meters. The collecting vessels, we have one of the valve which is connected to the timer and counter. Emergency run ladder 0000 4-digit number. The purpose of the ladder is to be operated in safe mode. Here we used in one NO and NC, normally open, normally closed input and output. Normally open, I is 0 was 0. For start the overall program, normally closed. For stop all the programs, output is run as per the input signal and its input for all the section of the column operating programs. Ladder 1 to 6. Operations of the fractions collections bottom of the column. The run output is taken as input for operate bottom section of the column when the vessel sensor not sense or holding tank valve get on as per timer instruction followed by binary output. Then conveyor motor will get on to move the vessel into right place. Otherwise the input is vice versa output of the conveyor motor get off. When the vessel sensor is sensed, the delay timer T on get on. As for the preset value 5 seconds. After the accumulation of the present preset time, the done DN signal get on. D for DN. Then binary output B3 get on. When timer binary B3 on, then as per requirement of level sensor, level 1, 2, 3, 4, 5, the holding tank valve turn on. The holding tank valve get on, then delay timer T on get on as per the time set time. After accumulation of the time, the done bit get open and turn the binary output of conveyor on. Data 7 to 11. Operation of the mobile phase loading. Top of the column. The run output is taken as input for operating top sections of the column. When the column level sensor 1 gets sense and column level sensor 2 not sense, then pump binary bit get on. When the pump binary on and required motor switches it on conditions, then correspondent pump will get on. This process are routinely working with the writing programs as per instructions involved in this method. Conclusions. The extraction of windowing from Catharon roses was successfully and considerable amount of extract was collected, identified using HPLC and TLC. From the two different stages followed, recrystallization proves to be the best and this the required and suitable model of automatic column chromatography was successfully done using PLC logic diagram. The following literatures we are studied and we are taken the hints from these are the literature surveys. And we thanks to everyone who are involved in my project, and we are sincerely thanks to our department, HODs and staffs.